Backyard Professor Math videos. We're going to do some more practice equations with the plug and chug because familiarity gives us the power to solve anything in mathematics. So let's do some good practice. We've got our values, y equals 8, r equals 4. I love doing these kind of problems because they really familiarize yourself with algebra and they really build your confidence. What if we're given an equation y squared times r minus 6? We plug and chug. This is a good algebra equation. 8 for y. This becomes 8 squared times r is 4. 4 minus 6. We solve the radical, not the radical, the exponent. We'll get to radicals in a little while first. We do the exponents. We know this is going to be multiplied by what's within the parenthesis, but before we do the multiplication here, we solve what's in the grouping symbols. Always, right? So 8 squared is 64. That's easy enough. We're going to multiply 64 by 4 minus 6, which is negative 2. And the reason why it's negative 2 is because the 6 is a larger number than the 4, right? We're subtracting a larger number from a smaller number, so we know that's going to be negative. A subtraction is always turned into an add of a negative. The negative sign is with the bigger number, therefore we know it's going to be a negative 2. Okay, I'm going to keep explaining that for a little while because I want you to get used to seeing what you're supposed to see and understanding what to do next. So this is simply 64 times negative 2. And this is 128, but it's a negative times a positive. Therefore, the answer is going to be negative 128. And it's that simple. Now, we've done some fractions, right? What if we're given y divided by r divided by r divided by y? Now, when I used to see these in school, I was so blown away, I didn't know where to begin. Where do you begin? You remember how to divide a fraction. You flip over the bottom fraction, you flip it, and then you multiply. We turn division into multiplication. If this was, so let's flip this. Here's how I like to do that. It tells me to flip it. So this is y over r times y over r. And you can see we don't even have to start plugging and chugging yet before we can get it into its accurate form. In fact, we can continue multiplying out, and if we didn't know the value of the variables, we would say this is y squared over r squared. And that's the right answer. You would be right saying that. If we didn't even know the values of the variables, that would be the correct answer. But since we have the value of the variables, let's do it plugging and chugging. This is y is 8. 8 over 4 divided by 4 over 8. We flip this one around to multiply, so the denominator becomes the numerator times 8 over 4. And now you can see that 8 squared and 4 times 4 is 4 squared, which is represented by r. But we also see these are improper fractions, so that 4 goes into 8 2 times, and 4 goes into 8 2 times. So this is simply 2 times 2, which is 4. Isn't that fun? That's kind of really interesting to see how fractions like that work. Let's do another one of those because we want some practice. We want to keep this in mind. In trigonometry and calculus, I promise, we'll be doing fractions all day long. So let's get used to them now. Now let's switch this fraction dividing business up a little. Let's say we're given r divided by y divided by r divided by y. We do the same thing. We flip the bottom fraction and multiply. So this actually becomes, when we flip this up and bring it up here, the y is going to be on top and the r is going to be in the denominator, so that we end up having r times y is r times y, and y times r is y times r. ry times yr. So let's plug this into numbers. Let's go ahead and solve, and that's the answer. Let's do the numbers. Let's say this is 4 over 8 divided by 4 over 8. We flip the bottom one over to multiply, so that this is going to be 8 on top and 4 on the bottom. And you notice something real interesting real fast here. We can cancel. When you multiply or divide fractions, you can reduce before multiplying out. 4 goes into 4 once, 4 goes into 4 once, 8 goes into 8 once, 8 goes into 8 once. 1 times 1 is 1, 1 times 1 is 1, and any number written in a fraction form over itself is simply 1. So that's kind of cool to see how you switch the fraction up a little bit from the previous example, and we end up with a very interesting 1 as an answer. These help us get confident with fractions, exponents, parentheses, the whole shot. I love these kind of exercises. Okay, let's do some more. This time we're told that a is equal to -9 and b is equal to 3. So how would we solve a times b? That's an actual expression. Easy, you plug and chug. This becomes a is -9 times b, which is 3. -9 times 3 is 27, but it's a negative times a positive, so it's a -27. Piece of cake. Well, what if we have something like this? A times b plus b times a. What do we do in this instance? Same thing. Put the number in, -9 times 3 plus b is 3 times a, which is -9. And this becomes -27 plus 3 times -9 is -27. And this becomes a negative plus a negative. We're starting in negative territory to the left of 0 at -27, and we're going to add more negative territory, so it's going to be a bigger negative number. If it was multiply, a negative times a negative is a positive, but here we're adding, so it's a negative plus a negative is a bigger negative, -54. See how that works? It's nice to be familiar with stuff like this. Now what if we're given AB minus BA? You see how you can invent your own equations? You can just rearrange several expressions. You can pick any number you want to let the variable be representing, and then work out several thousand equations. You do this, and your confidence in algebra and your capability of solving problems will become immense. This is wonderful. This becomes -9 times 3 minus 3 times -9. This becomes -27 minus a negative 27. Watch the signs when you're doing this. This is still a negative 27, but we're subtracting, so it's a negative minus a negative, and that gives us a double negative. And the way to handle the double negatives is this is the opposite of the negative 27, so we negate the negative. Negative 27 plus 27 equals 0. Isn't that nice? Let's do another equation. What if we're given a plus b, if I can write that good, minus the absolute value of negative 4? We know how to do this. We plug and chug first. A is negative 9 plus b is 3 minus the absolute value of negative 4. We know how absolute value works. It's all about how far away from 0 this number is. So next we do the absolute value. Negative 9 plus 3. Actually, we don't do the absolute value next. We work from left to right, always. Negative 9 plus 3 is negative 6 minus the absolute value of negative 4 is simply 4. So we end up with negative 6 minus 4. And we can always turn subtraction into addition. This is the nice thing about algebra with the integers. We can make that negative 6 plus, and we're adding another negative 4. This simply equals negative 10. Not that tough, is it, you guys? Kind of easy. What if we're given the absolute value of negative 5 plus the absolute value of negative 6 minus a times b? See, we no longer have to be intimidated by all these difficult looking equations once we learn the operations. That's kind of cool, isn't it? Well, the absolute value of any number is going to be positive, so that's simply 5. Same thing with plus negative 6, but it's the absolute value, so that's going to be simply 6. And we're going to subtract negative 9 times 3. But we're subtracting this number, right? So working from left to right, we do 5 plus 6 is 11 minus negative 9 times 3 is negative 27. And again, we have our familiar double negative, 11, and we negate the negative. 11 plus 27 is 38. And that's how those absolute values work. Piece of cake, isn't it? Let's do another equation where we're given the absolute value of negative 3 plus the absolute value of negative 10 plus a divided by b. We understand how to do absolute values. The absolute value of 3 is the distance of 3 from 0, which is always going to be a positive number. The same thing with negative 10. The absolute value of negative 3 is 3 plus 10 plus a is negative 9 over b, which is 3. So then we work from left to right, and we solve the equation. 3 plus 10 is 13, plus negative 9/3 is an improper fraction. We have one negative at the 9, so we know it's going to be a negative number. 3 goes into negative 9 3 times, but it's a negative. So we're beginning to the right of 0 with positive 13, and adding a negative is exactly the same as subtracting, right? So this simply equals 10. That's nice. That's a very nice. All right, let's change up the values. S, we're told, is the value of absolute -4. T is the value of absolute 7. So what does ST equal? -4 times 7. Except we're told that this is the absolute values of these, and you cannot have a negative absolute value. So the -4 is simply a +4. Actually, to write this correctly, do it step by step. -4 times 7. And then this becomes 4 times 7, which is just 28. It's not a big deal. What if we're given S minus T? The absolute value of -4 is 4 minus the absolute value of 7, which is just 7. A subtraction we can turn into an addition. This becomes 4 plus -7. 7 is the larger value than 4. It has a negative, so the answer is going to have a negative. The difference between 7 and 4 is 3, so that's going to be a -3. You see how that works? Very easy. Now what if we're told to calculate S plus T over 11? To plug and chug this, we have the absolute value of -4 plus the absolute value of 7. All of that is divided by 11. That's how we would write that out, plugging and chugging. We know this is 4 plus 7 over 11. We know this is 11 over 11, and a number over itself in a fraction, any number, is always just 1. See, that's not so bad, is it? That's actually kind of easy to do. Sort of fun to get us used to seeing absolute values. We're trying to work as many different kinds of operations and equations as we can so that we can become familiar with the algebraic way of solving equations. What if we're told S minus 3 squared? Well, we know the absolute value of -4 is going to be 4. So this becomes 4 minus 3 squared is 9. 4 plus -9. 9 is larger value than 4. The difference between 9 and 4 is 5. The bigger number has the negative, so we know the answer is going to have the negative, and that just simply becomes -5. What if we're given an equation to solve t plus 2 to the 4th? We plug and chug t, the absolute value of 7. This becomes the absolute value of 7 plus 2 to the 4th. Absolute value of 7 is simply 7 plus 2 to the 4th is telling you multiply 2 by itself 4 times. 2 times 2 times 2. So this is 7 plus 2 times 2 is 4, times 2 is 8, times 2 is 16. 7 plus 16 gives us positive 23. Both numbers are positive, our answer will be positive. And that's essentially all we're doing with that, to solve that. Easy once you start working them, isn't it? Just take it systematically, step by step, in the correct order of operations, work from left to right, and solve the equations. And before you know it, man, bing, bada, boom, you're doing algebra. Really. Fun stuff. Okay, we're given new variables with new values. H, we're told, equals 2 squared. J, we're told, equals 10 squared. On that information, how do you solve H minus 4? H minus 4 becomes 2 squared minus 4. 2 squared is multiplying 2 by itself twice. That becomes 2 times 2 minus 4. That becomes 4 minus 4, and the answer is 0. Piece of cake. Now, what if we change this up a little? What if we're told to solve h divided by 4? First we subtracted by 4, now what if we divide by 4? Now, h is still 2 squared over 4. We know 2 times 2 is 4 over 4, and that answer now becomes 1. So it's interesting how subtracting the 4 gave us 0, but dividing by the 4 gave us 1. Fun to play around with these. What if we're given the variable h divided by j? We plug and chug. We have 2 squared divided by j, we're told, is 10 squared. We do the exponent values. 2 squared is 4. 10 squared is 10 times 10, which is 100. We can reduce this fraction. We know 4 will go into 4 one time. We know 4 will go into 100 25 times. So that equals 1/25. That's how to do these kinds of plug and chug equations that are very helpful to get us experience with practicing fractions, exponents, absolute values, subtract, add, multiply, and divide. I think I've got just enough time for a couple of more. What if we're told to divide j by h? Now we have j, this becomes 10 squared over h, which is 2 squared. So this becomes 100 divided by 4. This is an improper fraction. We get to practice our improper fractions. 4 goes into 100 how many times? You divide 4 into 100. 4 goes into 10 twice, leaving you 8. Remainder of 2, drop your 0. 4 goes into 25 times. So the answer to this is 25. It's that simple, isn't it? Hey, four-wheelers! What if we're given j divided by h plus 6? Now it gets a little more complicated because we have 2 different operations. And that's great. This is good practice. J, we're told, is 10 squared divided by h, which is 2 squared, plus 6. So this becomes 100 over 4 plus 6, which becomes 100 over 10, an improper fraction. 10 will go into 100 how many times? 10 times, because we know 10 squared equals 100. And that's how to do it. Sounds like I've got shooters out here. I'm going to go ahead and go. I don't want to get shot today. I want to do more math. So thanks for watching my Backyard Professor videos. Happy calculating. Have a great life. And I will see you in the next video.